on to volume of prisms. On YouTube, your class is tagged, not tagged, it's titled 4.1. So when I upload the live classes, you can watch the others if you want, because of other groups, they're learning the same thing like you, but if you want to watch your particular class, it is titled 4.1, because you're my full group of students. Okay? So 4.1, 4.2, 4.3, and it continues all the way. So this is your 4.1 class. And so today's topic is going to be volume of prisms. We're almost near the end of this topic. Almost near the end. Alright. So we do have some things that we need to discuss before we get into the calculation phase of this. We need to know what the definition of volume is, and we also need to know what is it that's a prism. What is a prism? Okay. What do these things look like? Do I see them? Do I know of them? So first off, let's start off with a definition for volume. Alright, so volume is the total capacity. Volume is the total capacity. Volume is the total capacity occupied by a three-dimensional prism. Volume is the total capacity occupied by a three-dimensional prism. Full stop. Volume is measured in cubic units. Volume is measured in cubic units. When we talk about cubic units, we're talking about cm to the power of 3, or it could be m to the power of 3, and so on. So as opposed to area that is measured in squared units, volume is measured in cubic units. So when you do your calculations in the future, your answer should have the unit of measurement raised to the power of 3. Okay. Now the next thing that we're going to be looking at here is in fact, prisms. Okay, what are prisms? In a nutshell, a prism, let's talk here first. In a nutshell, a prism is a figure that contains 3 dimensions: length, width, and height. In a nutshell. So a prism is a 3D model. So prism is a 3D model consisting of 3 dimensions. Consisting of 3 dimensions: length, width, and or height. Now there's some other synonyms that we use for length, width, and height. For example, height. Height is oftentimes misinterpreted as something that is always vertical. Okay? But that's not always the case. Because if I take the bottle and I turn the bottle sideways like this, then the height of the bottle suddenly becomes the length of the bottle. Okay? So height can be vertical and height can also be horizontal depending on the orientation of the prism. Okay? So you might see where length is used interchangeably with height. For width, sometimes you'll hear textbooks, formula books, practice papers, they'll use the word breadth at times. Okay? Breadth. So breadth is also another word for width. And length is always going to be length. Okay? Follow? Is there a problem? Okay. Alright, so it's 3 dimensions, one of the two. Okay? One of the three. So now that we have, so to speak, an understanding of what is volume by definition, and we have an idea of what is a prism, we need to look at the different types of prisms. Do I see these things every day? You do. You actually do. Can I raise? So looking at the types of prisms then. And for the types of prisms, we have about 8 of them. There's about 8 of them. So the first one is in fact known as a cube. And so an example of a cube is actually a dice. So if you know what a dice looks like, then you know what a cube looks like. So you know what a dice is, a lulu. So you know what it looks like, then you know what a cube looks like. Okay? Or a perfect box. Okay? A perfect box. You have different types of boxes. You have cuboid, you have cube. So you have to look at a perfect box where the height, the width, and the length is the same. 2. Cuboid. And an example of a cuboid, if you're wondering if you've ever seen a cuboid before, you have. Everybody in here eat cornflakes. So a cuboid, an example of a cuboid is a cornflakes box. So if you know what a cornflakes box looks like, then you know what a cuboid looks like. Or it could be a dresser drawer. Notice how your dresser drawer is flat. It could be an aquarium or a fish tank. Yeah, a fish tank. If anybody has a fish tank or you've ever seen a fish tank, you see how it is kind of flat but very wide. Okay? Or a flat box or a sand box. But I kind of like using cornflakes box as an example. What I like to do, guys, is when I'm teaching this topic, I find that the names, the mathematical names don't agree well with students. And when you start to learn all 8 of them, then it becomes jumbled up. You don't know which one is which one, you don't know what it looks like. So what I do is that I try to connect something that is in real life that you have to encounter on a regular with the mathematical names. So if I say cuboid, you're thinking cornflakes. If you think cornflakes, then you more than likely know what the cornflakes box looks like. A cube, a dice. Everybody plays with a dice, or has played with a dice. So you know what a cube looks like. Next. This one doesn't need any introduction. A triangular prism. It's a giveaway. So does the name alone make you know that it's triangular related? Okay? But what exactly is a triangular prism? Have you ever seen this before? You have. Okay? You have. Yes. Pardon me? No, that's a code. So a triangular prism And yeah, that's a very good example of why I do what do the way I do. Because you see, she get it confused in terms of she used a birthday hat to describe a triangular prism. So she's connecting something that she knows in real life with the math, but it's just not very accurate. So an example of a triangular prism would be a goalpost. Goalpost. Just imagine how the goalpost look. Goalpost. Football. Goalpost. So if anybody here has ever watched football, played football, seen the gameplay, you know exactly the structure to which them kick the ball in to send the score a goal. So if you can visualize what that looks like, then you just visualize what a triangular prism looks like. Okay, in a moment I'm going to draw it. Okay, in a moment. So when you see it, you're supposed to know it's a triangular prism. Alright, another example of a triangular prism would be a tent. Okay, if you've ever watched movies before, or you've ever been camping before and you set up your tent, then you realize that the tent, right? I'm not sure if you know the tents that when you zip it down in the center, you can walk inside the tent and sleep on the floor, right? Big tent. So that's a triangular prism. So I like to use the word tent or goalpost. Talk to me. No, pyramid is a prism itself. Pyramid is a prism itself. That's also one of the 8. So the triangular prism, it's sort of a triangular prism, but we call it a triangular pyramid. So a pyramid in itself is a prism. Triangular prism is a little different. So a tent or a goal post for football. That means you don't know what a football goal post looks like.
You know what it looks like? Like when you go by the side like a one triangle,
yeah, who said them don't get what the goal post looks like? You know? You got it? Okay. 4. The next one is what we refer to as a, well, I think the correct name for it is a circular prism. Not thick. You know? It's a lot easier when I say a circular prism, but oftentimes, as I said in textbooks and formula books, just math books in general, you'll hear them refer to it as a cylindrical container. So a cylinder is what we use to represent a circular prism. An example of that is obviously like a glass or a water bottle. For example, this one is a cylinder. It's an irregular. Like a glass, like you throw water in a glass cup. A cup, yeah, a cup. A mug, a cup, a glass. This is also a cylinder. It's an irregular one. Why? What makes it irregular is the fact that the bottom is larger than the top, so it makes it irregular. When it's regular, then the exact measurement of the top is the same as the bottom. So an example of that would be like a barrel, drum, barrel, drum, glass, a cup, a mug. All of those are examples of cylindrical prisms. Okay? They say Max they run me every day. It is. You just don't think of it like this. A paint pan. That's also an example of that. There's so many different types of prisms. So many different types of circular prisms. Okay? So I think I prefer to use a barrel as my example. It's easier for me to remember it that way. So a barrel or a mug. So the 5th one is a trapezoid. A trapezoid. And again, the question still begs. Right, it has a trapezium. It's related to the trapezium, which we just learned the other day, last class. So the trapezoid, the question still begs, have I ever seen this before? The thing with math, guys, is that when you say math is around you every day, but people in general don't think about math on a regular. And sometimes they're working on mathematical structures, they just don't know what the name of the structure is. For example, have you ever seen a ramp before? You've ever been somewhere where you cannot climb up the stairs, so you have to be pushed up the stairs in a wheelchair?
Yes.
So that just visualize that structure. Visualize someone being pushed or you pushing someone up something slanted, and when they go up the slant, it goes flat. That is what we call a trapezoid. Okay? Or it kind of looks like, you know, like what old people used to use where they take something and catch the door bottom so that the door don't slam. Notice how it cut? It cut in such a way that you can slide it underneath the door bottom, but as the door is coming, it hits on something that stops it. Right? So the back of it is tall and the front of it like slant, like so. So that visualization, that's what you call a trapezoid. Okay? So I just kind of like to use the word round for this. 6. We have parallelozoid. Question? We have parallelozoid, but it's not really a thing. It's a prism. It can be considered to be a prism. I don't want to leave it out because yes, I'm being recorded. So I don't want to leave it out and then somebody probably like, oh, so you didn't teach us about parallelozoid. It's a thing, but it's not something we really talk about. Okay? To me, a parallelozoid is like a badly cut. It's like a badly cut piece of wood. It's like you have a piece of block of wood, and you chop piece to yourself, and then you chop piece to yourself. So it's like you're slicing it off, like so. So it's like a badly shaped, it's like a badly cut piece of wood. But it's not really a thing per se. You're not going to go into it. You probably go on Google and type it in and be like, oh, what's a parallelozoid, and a picture comes up. But to say it's a thing, we don't. Nah. So we skip that one. Okay? And we move to what is known as the sphere. The sphere. An example, anybody has an example of what a sphere is? Right, a ball. So for those of you guys who, you know, I always say ignorance is bliss. If you know, you know. If you don't know, you just don't know. Right? And if you don't know, you're probably going to use what you know. But persons often say the ball is round, and that's very, very inaccurate. A ball is not round, ladies and gentlemen. A ball is spherical. A ball is spherical. The earth is not round. Okay? The earth is spherical. The earth is not oval neither. Okay? The earth is spherical. So the earth, right? You don't want to use the word, I just don't care. You know? I'm talking, you know me. Jamaicans are like that. When they don't know the right thing to say, not just Jamaicans, people in general. When they don't know the right thing to say and you're correcting them, they say, you know what I mean. I don't know what you mean. A ball is not round. A ball is spherical. The earth is spherical. Okay? I'll just pretend like I know what you mean. Pardon me? The ring light? The ring light in this case, looking at it from this perspective here, it is round. Because I'm looking at it from a 3-dimensional perspective. But it's because I can't really wrap my hands around it. I wouldn't say that this is spherical. This would be round. This would be round. But like a globe, yeah. But if it's a case where you can put your hand at the back, round it and hold it in your hands like so, then we call that spherical. Yes, that is correct. 3D. So with something spherical, it's 3D, right? This is kind of 3D to an extent, but it's like you can't really feel it. So I wouldn't really tag this as being spherical. I would still say the ring light is wrong. Okay. But yeah, you get the idea. So a ball, the globe, football is spherical. So I like to use football or a ball as an example. So I don't ever forget what the sphere looks like. 7, as Christina was saying earlier, the cone. The cone. So she used the perfect example, a party hat. A party hat. And the cone is a type of pyramid. We call it a circular pyramid. Okay? So the cone, an example of that would be a party hat. Or a cone itself, you know, ice cream cone. Yeah. So cone, a party hat, And or we call it a conical prism. Conical prism means that it's a cone. And then the last one is, of course, pyramids. Pyramids. And there are different types of pyramids. There's not just one. There's three, actually. Three? Or more, maybe. But I know about three, personally, off the top of my head. For the pyramid, we have a square pyramid, where the base of the pyramid is a square. We have a triangular pyramid, and we have a circular pyramid, which is the core. So what exactly is a pyramid really? How do you actually recognize a pyramid from any other thing? A pyramid basically has an apex. So you have lines that are converging at one point. So anything that has an apex is a pyramid. A cone has an apex. The lines disappear at one vanishing point. So that's an apex. The pyramid, same thing, and they circle. Yeah. Pardon me? What about it?
And then you will be required to look.
That's the apex. So the pointed part is called the apex. Oh. So this is a line, no? Pardon? Yeah? Square pyramid. So you have a square pyramid that looks like this then. And you have the triangular one. So all in all, pointed part. So circular pyramid, square pyramid, triangular pyramid. Got it? Okay. Alright, good. So now that we have all 8, right? These are the ones that you will encounter. You know, you have some that you encounter more than some. So you're going to find that these ones with the asterisk are the more common ones for CSEC. For most exams, not just CSEC. You know, CSEC is a Caribbean exam. But remember, say math bigger than the Caribbean. So these ones with the asterisk are the more common ones. The sphere, I haven't seen this in a while. I really I've not seen the sphere on a CSEC paper since 2007. So that's so long. 16 years ago. So I have, no, I used to study. maths. So I haven't seen and I follow the trends of the CSEC paper. So I haven't seen this. Correct me if I'm wrong. If there's a sphere that came on an exam paper, and I know all the exam papers. And the cone also comes up now and again. Okay? Good. Now, all of what you've just seen, all of these prisms are what we refer to as uniform prism. And what we mean by uniform prism means that every aspect of it remains the same, even if you chop it up in pieces. So it's uniform. Okay? When it becomes irregular, when it's not uniform or not, when it's ununiform or not uniform, okay? When you chop it, it gives you one different shape. If you chop it so, it gives you one different shape. If you chop it so, it gives you one different shape. That's when it's irregular. Okay? And you also have what are called composite prisms. Okay? If I were to draw, for example, a house, a replica of a house.
For example, I might look at Natalia. You have been doing an excellent job in class. Your grades in the last 2 exams.
That's a replica of a house, or what we would call a house, right? This, you can't even give this a name. You can't say that this is a triangle. It looks like a triangular prism. You can't say it's a trapezoid, you can't say it's a sphere. It doesn't have a name to it. So this is what we call a composite prism. More than one prism makes up this prism. So basically what you're looking at here is a triangular prism that is mounted on top of a cuboid. So a triangular prism, notice the triangular prism at the top, mounted on top of a cuboid, or it could be a cube, depends. Okay? So you have composite prisms and you have irregular prisms. An irregular prism would be an example like this one. This is irregular because the top is different from the bottom. So understand the difference between regular, irregular, and regular, and composite. Composite, the word composite means more than one. Yes, it's this. Pardon me, talk, I'm hearing you. Your voice is lost in the atmosphere. You're saying. Okay, a composite prism is where you have more than one prism being put together to make another prism. Okay? Like this morning, I was looking through a textbook and I saw this one. I saw this one.
Alright, moving on to the next one. Always communicate the feeling that you hear at home. Sorry. Always communicate the feeling that you hear at home.
It's like basically something you put in the water when you want it. It's like a buoy. B-U-O-Y. We put in the water out to the sea. So it's basically like something that floats on top of the water. It's like an orange, yeah, the orange thing. So basically what this is it's a cone that's mounted on top of a cylindrical solid. Okay? So you have to look out for these things when you see them on the outside. Right? It's not that the mass is hard. It's just that you just don't know what these shapes are. It just looks very weird. You don't see them on a regular, so it looks like, what the hell is this? So that's one that I saw this morning. Now, we have to look at something known as C-section. Not your C-section. Not female C-section. It's not biology class. I just couldn't bother to write the word cross-section. Okay? So don't write C-section, just write cross-section. I'm shorthand. So it's cross-section. That's another aspect of measurement that you guys need to be familiar with. Okay? C-section, cross-section. So what exactly is the cross-section? Well, for one, the cross-section is what gives these the name. Okay? The type of cross-section is what gives the prism your name. And in a moment I'll tell you what that means. Okay? But let us get an intuitive idea. Right? Without any definition, if you look up cross-section in Google, they're going to give you a whole array of different, when you read it, you're probably not going to understand. But in layman's language, in a nutshell, to simply put it, a cross-section is when, like, let's say you slice the bottle in a half, right? And you keep slicing the bottle. Every slice looks the exact same way. It's circular. Imagine you go into a store, a supermarket, and you see cheese. Have you ever seen how them pack up the cheese? Notice that all the cheese are all triangular. It was a big cheese before, but it sliced up, and as it sliced up, the slices are smaller in area and smaller in volume, but the face is still triangular, as long as you cut it in that same line. Obviously, if you change the direction of the cut, it's going to change the whole cross-section. But if the slice remains in that order, the only thing changing about the prism is the length of the prism. You don't get a big piece of cheese, right? You get a big piece of cheese. Okay? Once you slice the cheese, the size of the cheese becomes smaller, but the face of the cheese doesn't change. Okay? Or the bottle. Okay? You cut it, cut it, cut it, cut it, cut it. Every slice will be circular. Okay? Will be circular. So in a nutshell, then that's what we refer to as the cross section. It's to simply put it, it's the face of the prism. Fine. The cross section, write that down, guys. The cross section is the face of the prism. Don't say front of the prism, because the cross section doesn't have to be at the front. It can be the top and the bottom, it can be the back and the front, and it can be the side and the side. So it's very important you write that the cross section is the face of the prism. Cross section is the face of the prism. This is so important towards your calculation because that's how you're going to know. You know, set aside from I gave you some things in real life that you can use as a guide to help you know what these are. You also have to know that the cube has what type of cross section? That's the question. So the cube has a square cross section. So the face of it is a cube, is a square. Imagine a dice. And I mean, I didn't have to tell you that because everybody knows that for a dice, the face is square. So it has a square face. The cuboid has a rectangular face. So if you go into the quiz or the exam, when you see it, you're like, which one of them okay? Is it the cube? Is it the cuboid? You're not sure. You think rectangle, you think cuboid. You think square, you think cube. So it's one of two. Okay? One of two. I mean, this needs no introduction, does it? Triangular prism has a triangular face. So it has a triangular face. Very good. So triangular face coming to that. So the triangular prism has a triangular face. But please note that this, just like when we were learning triangles earlier, it was a very sensitive topic in terms of the formula. When we were learning the triangles, we learned that a triangle doesn't have a standard formula. It is not half base times side, what you guys often say. I don't know, what's the area of a triangle? Half base times side. That's not always the case. Because we've learned so far in this class that a triangle can have 3 sides, all 3 sides given to you, that will be Heron's formula. It can also have a base and a height, which is obviously half base times height. And it could be a triangle that has 2 sides and the angle between the 2 sides. So it's a very sensitive prism because it's depending on what triangle is given to you. Is it a scalene? Is it an isosceles? Is it an equilateral triangle? Is it a right angle triangle? It depends. So very sensitive prism when we get to that. As my friend here says, that the name? No, Britannia. As Britannia said that the cylinder right away has a circular face. It has a circular face. And again, an example of that we said is a glass, a barrel, a water bottle, a cup, a mug, you know, a paint pan, as she said, are examples of that. A trapezoid obviously needs no introduction. It has a trapezium face. The sphere, it doesn't, right, so it has a cross section, but the cross section is not going to be at the front. The cross section is going to be on the inside. So you have to slice the sphere vertically. And imagine a melon. And a melon is not. A melon is more, is it more oval? Do we say that a melon is more oval? Yes? But even if it's oval, we don't chop the melon, boom, right in the middle. You can see the elliptical, okay? So melon has more of an elliptical cross section. You know what an ellipse is, okay? Say that again. Right, also the football goal would be an example of triangle. That's what we said earlier, right? Is that what you're saying? Okay. So the melon, if you know what an ellipse is, okay, let me give you an example of what an ellipse is. There's no cup here. Alright. So when you look at this, what do you see? Circle. Circle, right? When you look at it from this perspective, when you're looking at it, you know it's a circle. But it doesn't feel like a circle, does it? It's more elliptical. So elliptical, an ellipse is kind of like looking at the circle from the top from a frontal view. So if you look at a cup, and you hold out a cup in front of you like this, and you're looking at it, you know it's a circle that is at the top of the cup. When you're looking at it, it looks very elliptical. That's what ellipse means. So a melon has more of an elliptical cross section. So the sphere, we say it has a circular cross section, but it's more on the inside. Okay? The cone also has a circular cross section as well. Pretty much the cone is the only prism that has one cross section here. Every prism has two. The square has a cross section at the top and the bottom, side and side, back and front. The cuboid has it at the side and the side, perhaps the top and the bottom, and the back and the front. The triangle has it at the side and the side. Okay? The cylinder has it at the top and the bottom, or the side and the side. The trapezium, side and side. Right? Depends on the orientation. The sphere has it right in the center, zoom out. And the cone has a circular one. The pyramid depends, because obviously if it's a square pyramid, it has a square cross section. If it's a triangular pyramid, it has a triangular cross section. And of course, if it's a circular pyramid, for example the cone, it has a circular cross section. So hopefully that little array of discussion there kind of gives you a perspective on what we mean by cross section. You remember as well? Was you talking prior to me teaching this? Okay. And the only thing you knew there was what? Ball in shape. Well, it's not shapes, they're prisms. A shape is different from a prism. A shape is a 2D. A prism is 3D. Right, so you see prisms, then you have to draw it. So that was the only thing you knew of it prior to this lesson. Right? So we learned something. So this is why, if you've ever done CSEC exam before, if you've ever done exam in general at all, and you find that in the future, if this ever becomes a challenge for you, it is simply because you don't understand the fundamental aspects of it. What a cross section is, what a prism is. You know, these little things are things that you have to know before you can dive off into it. Okay? Alright, so we did a whole bunch of stuff. We attacked something in real life to name up the prisms and tell you how it gets in space. It's no time to draw them. However, you're not tested on exams on how to draw them. I'm just drawing them because I want you to see how they look. Okay? But you don't have to draw them. I will just Google the images and I will just send them to you in the group. And at any time convenient to you, you can draw them out if you want. Or you can just have them as a file. So don't spend too much time. You cannot draw them. Just leave the space for them. Alright, so we actually, we've been doing a lot of talking and writing, but nothing visual has come to life, you know? We have an idea, we know what a dice, a cornflakes box, tent, barrel. It's time to see what they look like. Now, in addition to that, give me a time check, guys. Give me a time check. Keep me up to date. Okay, good. You're on time. Alright, so in addition to us drawing the diagrams, it might be tingling in your mind that, wow, this is a lot. Am I supposed to remember the formulas for all of these? No. That's a waste of time. The only thing that you're going to need to know about this is one single formula. As a math student, you're gonna have to develop the ability to derive the formula as opposed to knowing the formula. Now, for me, I've been doing math for a very, very long time. So if you ask me what is the formula for a cylindrical solid, I'll be able to tell you that it's pi r squared h. But how we know that? Because I have to do it every year. But for a random student, you need to ask them what is the volume of a cylindrical container. They're not going to remember. Okay? But if they have a way in which you can derive the formula, derive meaning that you can look at one thing and it leads you to the next. So you're going to learn how to actually derive the formula as opposed to studying the formula. I don't want you guys studying 8 formulas. That's too much. I've never had to study these. Never at any given point. Not in that lifetime that I've been teaching. All I know is just one single formula, and then I just use it and direct me to whatever I want. So what is this formula? We're on the topic of volume. May I erase? May I erase? We're on the topic of volume. So that means we need a formula for volume. I need to make mention that, listen, I need to make mention that I want to have a fundamental rule in this class. Okay? I want to have a fundamental rule. Because I feel like I have to be repeating myself so many times, and even on the quiz paper, I find that persons got questions incorrect because they didn't. They keep forgetting to do this. Here's the fundamental rule. Every time that I teach you something that is formula based, make sure, say, uno, write down the formula. If you don't write it down, you guys are never going to stop guessing. You're always going to guess, should I divide, should I multiply, should I add, should I subtract? Once you write down your formula, and based on the information given to you about the question, and you take the numbers and put them in your respective position, the formula will tell you what is it that you're looking for and what you need to do to derive that answer. It will tell you, because you're going to either see a multiplication sign, or an addition sign, or a subtraction sign, or a multiplication sign. You're going to see one of them. So what's the formula that we're looking at there? So that's the fundamental rule. Always write down your formula. What is the formula that we're looking at? We're looking at the formula V equals A multiplied by H. This one single formula will help you to derive the formula of every single one of the prisms that were just listed. Oh sir, how are you going to use this one formula to derive all of those? Because the only thing you need to know is what does A represent. And obviously, I mean, H is kind of self-explanatory. H is always going to represent the height. But the problem with this question is most persons don't know what A represents. And too many times the person will be like, oh yes sir, it's obvious. A represents area of what? Area of the C-section. Cross-section, that is. So the area, so the area of the CS. When you see that letter A, it is not just the area, it has to be very specific. The area of what? Is it the area of the top, area of the front, area of the back, area of the bottom, area of the side? What is the area of what? It's the area of the cross-section. And we just went through a whole entire, 15-20 minutes of discussing cross-section, what it looks like. It's the face of prism. Please note that a prism has 2 cross-sections. Which prism has only 1? Very good. The cone is the only one that has 1 cross-section. Okay? The pyramid also has 1 cross-section. Okay? But everything else, cuboid, triangular prism, has 2 cross-sections. And that's how the cross-section is easy to be identified, because it's 2 of them. When you look at the prism, you're going to see 2 distinct shapes, or 2 identical shapes. Sometimes at the top and the bottom, side and the side, or front and the back. That's how you know exactly where the cross-section is on the line. So the A stands for the area of the cross section and the A stands for the height. But let's pick up in again. Remember when we just started the topic since evening, earlier, in the first 5 minutes of the class, we had looked at the fact that the height can be the length of the prism. Because at the moment here, for this particular prism here, the bottle has a height. But if the bottle was to be turned towards the side, then the bottle no longer has a height. The bottle now has a length. Yes? Or picture a cornflakes box standing up. It has a height. But when you're in your class in the kitchen and the cornflakes box drop down on your face, the box now has a length. So you may see interchangeably that I will refer, we will refer, textbooks, formula books will refer as V equal A times L. So it's not just A times H, it's A times L, depending on the orientation of the prism. So, I don't understand. Maybe so you're telling me that you're going to use one formula to derive everything else? Of course. Yes, Christine. Pardon me? V stands for volume. Volume, yeah. V stands for volume. Thank you. Oh, very bad teacher. No, not that bad. As in bad, not bad as in that talk. Volume, okay? V stands for volume. So far you've seen it in all the examples that I've taught you in our 4.0 class, okay? The class prior to this one. I've showed you so many times over that if you think that it's only volume that we're going to ask you for, you go and examine your next mistake. It's going to reverse. And you've seen how we have struggled as a group to first learn how to reverse the formula. Yeah, that was the part that really messed up a lot of students. You know, when you have to go backwards. When they give you the volume and ask you for the area, or give you the volume and ask you for the height. Okay? But we've done it. In every single topic, we have done it. Can I erase? Can I erase? So remember, no matter what you've heard tonight, you leave the class with one thing in mind. What is it? That's the only thing you leave the class with. So if you decide to forget something that you learned tonight, you can forget everything else. One advice, do not forget everything else. But if you choose to forget something, try not to forget this. V equals AH. Now again, do not place a lot of emphasis on drawing it, okay? So for the cube, we're looking at so that's my cube. Okay. And so the cube, because the cube has a square face, we know from our 4.0 class that the square has all sides equal. So with the cube, we do not differentiate between the length and the width and the height. There is no difference between them, they are the same. So we say that the length is the length is the length. Length, length, length. So the cube, the length, the width and the height are all the same. Hence, it's a cube. It's a square face. A square has equal sides. So length, length, length. But how do we derive the formula for this? If you leave this class tonight and take up the paper or the textbook or whatever and you see this, how do I derive a formula for the volume of a cube? Well, you start off by writing down what we should not forget. Writing down there, which is V equal A times H. Now, it's time for you to figure out what is A. So V equals A. A stands for the area of the cross section. The question is what kind of cross section does this have? A square cross section, a square face. What is the area of a square? Length squared. You learned that from 4.0 class. Length squared. That was the very first thing you learned when we introduced the topic of measurement to you. just length squared. And we know so the h is going to be the same thing as the length, so it becomes length again. Now, you haven't done algebra as yet, but there's two L's here, and there's a single L here. So how much L in total? So basically we can simplify this to mean V equals L cubed, or L to the third power. Therefore, that is the volume of a cube. Do not go home and try to study and force your brain to remember that V equals L cubed is the volume of a prism. Because when you get the other 7 prisms, they will all become jumbled up. So again, what do we leave the class with tonight? V equals AH. From there, so you can go in any direction that you want. Okay? Any direction that you want. Boy. We're not getting into the calculation. Okay? In our 4 point, in our next class, that's what we're calculating. But in our next measurement class, we'll get into the calculation phase. I'm only picking up 2 of them and showing you how we derive the form. So the cuboid, oh, and if I didn't compliment you, as a group, evening school students are doing a little bit better as a group than the day school students in terms of the performance. I did find that everybody, I think most persons in here, your percentage went up a little bit. If you did the last test and you got a grade, if I remember correctly, not everybody, some persons still literally just, but for most persons, your grade went up a little bit, which shows signs of improvement. And that's all that I ever ask my students for. I don't want no bright students in the class, like Rihanna. I don't want no bright students in the class, because if you're bright, you're not supposed to be in front of me. You're supposed to be competing with me. Okay? So what I want is that I want each and every time that you do an exam, even if you fail the exam, I want you to look back at your mistake that you made, make the correction, and as Kobe Bryant says, get over yourself. It's not about you. Every time you feel bad with yourself. Like, nobody cares. What we care about is when you make a mistake, you look why you're making a mistake, where you made the mistake, correct yourself, so that the next time when it comes around, you know exactly what to do. I just need to see improvement. Like, for example, someone got, not talk about your grades, he got 30% in the first quiz, and he got 45% in the second quiz. That shows improvement, and the mere fact that I'm respectful of that is that he gets a higher grade and a more difficult exam. So it shows that that's double improvement. Improvement in the grade, and the mere fact that the paper, every time you get a quiz, it's harder than the one before. So that's improvement. And our person in here is them bump up, some of them go to 50s, some go to 40s. You're exactly where I want you to be. Right here, so, is what I can work with. I can't build on something that is 90%. I can build on something that is 20%, 30%. That's what we want to do. Alright, so boom, 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 boom. That's my cuboid. In this case, it looks like a flat nut, but I could draw it like this instead.
So first, what you need to do is kind of
I could draw it standing up like that. No. So V equals what? A times H. Now, because the cuboid has a rectangular face, we know from 4.0 class that a rectangle, the length and the width, has to be differentiated. So this is the height of the prism, this is the width of the prism, and this is the length of the prism. This is the what? This is the height of the prism, this is the length of the prism, this is the width of the prism. So the width at the side, the length at the front, the height at the standing up. Okay. And so therefore, because it has a rectangular face, then the area becomes length times width, obviously times height. Therefore, you just got the volume formula. V equals L times W times H, or LWH. Who is Satrina? Kayla? Let's move on to our cylinder. Give me a time check, please. Give me a time check, guys. Keep me up to date. 5:15, we're on target. So a cylinder, or a cylindrical solid. So we have several examples of the cylinder.
No, when you're ready to relate to us, the following is complicated that you can start to teach us. First off, what do you do the first one here?
So it can be standing up and it can be lying down. So in this case here, it has a height, but then you might be asking then, sir, where is the length? Where is the width? Because it's a circle, we know from the 4.0 class, which was the previous class, you'd have already known that when it comes to the circle, we don't deal with length and width, we deal with radius and diameter. So therefore then, we'll be looking at the radius, we could be looking at the diameter for this one, diameter, or it could be a case where we're looking at the radius. It really comes down to the radius. Huh? No, it doesn't mean, no, I just chose one. So both can be diameter or radius. So it depends. But we know, so once it's a diameter, we know so we can divide it by 2. I don't think there's going to be a case where you get the radius and you have to convert it to a diameter. If so, the double. Alright, so as she said, and I'll put that out here, she was asking if when it's lying down it's a radius, not necessary. It can be lying down and have a diameter. It can be standing up and have a diameter or radius. What's the formula for any prism? V equals AH, we don't stop saying something stick. So you go home and you say that you have bed, you're having a shower, you think you're mad. V equal AH, V equal AH, V equal AH, V equal AH. V equals AH. What kind of cross section does the cylinder have? A circular cross section. But in the 4.0 class, you would have learned that a circle's area is what? Pi r squared. Very good. So pi r squared times h. It's going to be h if it's standing up. But again, v equals pi r squared L is no different because it's lying down. Right. And L is lying down. Okay? So it's v equal pi r squared L. And for the last one, right, because I've only selected a few, I can't really go through all of them for this class. In the next class, I might be able to, in the 4.2, and that's interesting before. Do the trapezoid? Do you want the triangular prism or the trapezoid? Let's do the triangular prism next class. Let's do the trapezoid. Make the triangular prism for last. That one is a little sensitive, so we need fresh brains for that one. We need fresh brains. So let's look at the trapezoid as the last one, guys, for this session. Separate aside from the fact that we know it looks like a round, it's very good that we can actually draw this.
It goes to the right of the center of the page.
So kind of, you know, it might throw you off, you know, when you see them, like, you might make a mistake and thinking that it's a triangular prism. But there is no triangle that is at the side. Is there any triangle here? Do you see any three-sided figure here? So for you to say, if you ever get thrown off, if that is your reasoning for confusing a trapezoid, three-sided, is there a shape here with three sides? None. So it cannot be misinterpreted as being a triangular prism. If that is your reasoning, then that means you have some lacking in knowledge when it comes to triangle and four-sided figure. But this cannot be misinterpreted for a triangular prism. Okay? So right at the side here.
So your center starts to the left, right of the
Beautiful.
center of your page.
That's your trapezoid. Again, what's the formula for any prism? One time ago, when this was hit me. What? And like V for age. Like, stop. What's happening to me? V for age. I want it to stick. And here's the sad part about it. Here's the sad part about it. It actually sticks now, you know. For most persons, I feel like it sticks. And the sad part is that they put it on the exam. The formula is the first formula on the front of your formula sheet on your question booklet. It's right at the top. But it's just like that. It doesn't give you a specific formula for a specific reason. Alright, B equals, what kind of face does it have? Trapezium. Please bear in mind, English is so powerful. I don't want you guys to think when I say face, it means at the front. Because people think like face has to be at the front. It's not literal face like my face. Face meaning front and back, top and bottom, side and side. So in this case, the side and side. Now, this requires you to know the area of a trapezium, which is what we did in the latter part of the last class, which is going to be A plus B. So it's A plus B times H divided by 2 times H. Oh no. H. Isn't that 8 squared? No. This will get a little bit interesting. But these two H's are different. I usually call one H1 and I call one H2. So they couldn't end the class nice and just make it easy. No, I'm sorry. We have to differentiate between the two H's. Okay? And it's not 8 squared. This H, and make a note of it, guys. This H here is the height of the cross section. And this H is the height of the prism. So H1 is here. H2 is here. H1 is the height of the cross section. And H2 is the height of the prism. This prism is lying down. So we could see that this is length. So what I'll do here is that, just so you don't get confused, I'm going to say A plus B times H divided by 2 times length. Just so you don't get confused. So the length here is going to be acting as this part here. Length. So in our next class, we're going to be looking at the triangular prism and how to derive the different formulas for them. And we're going to be looking at some application examples, looking at density. Hopefully we can get there. And then we're going to dive into some other stuff. If you feel free again, as I said, if you went through this class, you phase out or you fall asleep, you can find this class on my channel. It's titled 4.1 volume of Prisms. You'll find it uploaded tomorrow night at between 5 o'clock and 8 o'clock. Okay? Have a good evening, everybody. Not Skull the quiz. I'm going to show them who you are. Where you going? Where you going? I'm going to show them who you are. You have to pass, no? You have to pass. Okay, alright. That is who skulled my quiz. See her there. Sculling my quiz. Running through the window. See her there.